So welcome to Increasing Pattern Introduction problem number 1. And it's a problem that it just extends what was done in the first lesson, trying to understand patterns and how to represent them in the 5 ways. So in this problem, you're given the first 3 figures in the pattern as before. And so as you look at each pattern, what you're really looking for is how is it changing? How does it change from this one, from figure 1 to figure 2 to figure 3? How does the pattern grow? And so if you look at this one, you can see that the upper section, this part here, in figure 1, 2, and 3 has not changed. And so that's a first observation. You want to try to identify things that are changing and things that are staying constant, as we say. So this upper section here, these are not changing, they're constant. So they pretty much stay the same. It's this bottom part here that you want to recognize and see, oh yeah, it's getting longer this way. So if I want to extend this pattern to figures 4, 5, and 6 to do at least 3 more with tiles. So I think I can see that the top is just going to be 3 each time, and the bottom's going to get extended 1 more each time. So figure 4, I think, based on this, should look like 3 here, and then 1, 2, 3, 4 more there. So there's figure 4, and then get figure 5 in here. So figure 5 should again have the 3 there, because that part doesn't seem to be changing, but the part extending down is getting longer. So there's figure 5, and then see if I can get figure 6 in here. I'll move this up a little bit, move this over. So there's figure 4, figure 5, and then figure 6. So there's those 3 on top, and then 1, 2, 3, 4, 5, 6. So again, I'm hoping that this pattern is pretty simple and obvious, since right now I just want you hopefully to learn the idea of looking for things that are constant and things that are changing and how they're changing in these. So here's figure 4, figure 5, and figure 6 in this particular pattern. And again, that top part doesn't change, but the bottom part extending down, I think of this like a T shape where the bottom part is getting longer. So when I go now to my answer sheet and start to show these, and I can just move that over and say, okay, here is my representation of figure 4 with the 3 across the top, and then there's 1, 2, 3, 4 here, and then 3 across the top, and 1, 2, 3, 4, 5 here, and 3 across the top. So that top part doesn't change, the bottom part continues to move along. So I'm going to go back to the original figure and just keep track. So I had 1, 2, 3, 4 tiles in this one, in figure 1. 1, 2, 3, 4, 5 tiles in figure 2, and 1, 2, 3, 4, 5, 6 tiles in figure 3. So fairly simple pattern where you can see it's just going up by 1 each time. So I would expect then for figure 4 would have 1, 2, 3, 4, 5, 6, 7 tiles. And then figure 5 should have 1, 2, 3, 4, 5, 6, 7, 8 tiles. Figure 6, 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles. So just what I would expect, increases by 1 each time. And so now I know that the 6th figure has 9 tiles, so I can fill that in here. And maybe you already know what the 10th and 30th figures have in them, but I'm going to go ahead and just fill in the table. And I know that the first figure has 4, so figure 1 has 4, figure 2 has 5, figure 3, 6, and I think it's We know from up above we have 7, 8, and 9. So now I can just continue 7, 8, 9, and that matches with our sixth figure has 9. So those match, and it's always good to kind of check and make sure that things line up. So the sixth figure has 9. The seventh figure I would expect to have 10 if this pattern continues, and then 11, 12, 13, and then the question would be what's the 30th figure, which we'll come back to in just a moment here. So the 10th figure has 12, 13, excuse me, 13 tiles. Look at my own paper here. 13 tiles in the 10th figure. And so now I'm going to go back to what I see in these problems, and you probably already saw this. I'm sure you're way ahead of me. Because this was figure 4. This is figure 4. What I see is the 4 here and the 3 on top. And then figure 5. So here's figure 5. What I see in figure 5 is the 5 here, and then again the 3 on top. And then figure 6, 1, 2, 3, 4, 5, 6. I see the 6 here, and then again the 3 tiles on top. So I always have this part plus the 3, this part plus the 3. So that's a constant. So what I see, if I write it down, is in figure 1. Figure 1, I see the 1 here, and then the 3 there. In figure 2, I see the 2. So figure 1, I see 1 plus 3. In figure 2, I see 2 plus the 3. In figure 3, I see 3 plus 3, and then 4 plus 3, 5 plus 3. So looking up to these here, here's the, see the 4 here plus the 3 on top. Here I see the 5 plus the 3 on top, and so on. So figure 6, there's 6 plus the 3. That's what I see. See the 6 plus 3, and then 7 plus 3, 8 plus 3, 9 plus 3, 10 plus 3. So what would I expect for the 30th figure? I would expect 30 plus 3, or 33 tiles. I'd expect a stack of 30 with a top of 3, so 33 tiles total. Now, a mistake sometimes people make is just simply taking the 10th figure and multiplying it times 3. And you see, if you did that in this case, 13 times 3 would not give you the right number of tiles. So you can't just do that. So you actually have to understand the pattern and how it's growing and how it's changing, how it's what you see happening determines what you get. Start with the figure number in this part, and then we put a 3 on top each time. So that represents that particular pattern. And we could even extend this down to the 0 figure. So the 0 figure would have 0 in the stack and still plus 3, which actually you would have in the 0 figure, you'd still have the 3 tiles from the top. It's a little bit more challenging when we start talking about negative, but we can actually, using some mathematics, talk about negative figure numbers. But we're not going to do that. Right now, we're going to move on to the other side of this, and we're going to do the graphical representation. So we've done our tabular representation. Sometimes it's a good place to start, because now we can go back to, if we have figure number 1, remember figure number 1 had 4 tiles in it. So now I'm just representing this on the graph. Figure number 1, 4 tiles. Figure number 2, 5 tiles. Figure number 3, 6 tiles, etc. So, and even So figure 2, 5, figure 3, 6, 7, and so on. And so now at some point you begin to see that I can, without really thinking about this, just continue this pattern. And I could actually take a ruler. Remember the 0 figure had 3 tiles in it, even that figure. If I start with sort of a 0, where would it actually start? Like our number system starts with 0. And so now I have a graphical representation. It extends in either direction, continues on. And so there's my graphical representation of this particular pattern. So you can see it's increasing at a regular, predictable rate. You could go on to as far as we went in either direction to find the number of tiles for any figure. And so now the equation that I'm going to come up with really comes back to what did I see? What did I see in this pattern? If I had figure x, in other words, x is the figure number, y is the number of tiles. If I think about what did I have here, if this is x, in other words, if the figure number we say is x plus 3, that will give us our y. In other words, if we have the figure number plus 3, we'll get the number of tiles for any particular figure in this pattern, which is what we want to be able to do, because now we can predict. We can say x plus 3 equals y. In other words, the figure number plus 3 gives us the number of tiles for any figure in this pattern. So I've said if this is figure number 100, you would know that it is 103 tiles. 100 plus 3 is 103. And the context for that is, again, the figure number right there. That part there represents the figure number, or x, plus 3. And here I have again the x plus 3. The x is equal to the figure number. And here again I have the x plus the 3 more on top. X again is the same or equal to the figure number for this. So there's my context of how I solve this problem. These represent the variable, the part that's changing, and this is the part that stays the same. So to find the number of tiles for any figure in this pattern, what am I going to do? I'm going to take the figure number plus 3. To find the number of tiles for any figure in this pattern, take the figure number plus 3. So basically now you have instructions, written instructions for finding the number of tiles for any figure in this pattern. Figure number 1000, you know, would have 1003 tiles. It'd be a stack of 1000 tiles tall with 3 across the top. And so now this pattern we can predict for any figure number, and we can do it in any particular context that we want, or any representation. We can look at the algebraic representation, we can look at it as a graphical representation, we can see it in the geometric context of the actual pattern, we have it in words as if we have a instruction manual for how to solve it, we can see the tabular representation of it in terms of how the numbers compare to one another. And so now we basically, this pattern is no longer a mystery to us. We have an answer that we can use over and over again. And so this pattern is no longer a mystery. It has been solved basically by determining how it's changing and growing each time. And every time we approach a pattern problem, we want to be able to do these things. Now again, this is a fairly simple pattern. Patterns become more complex and require more looking at them and how they're changing and what parts are staying the same and how they're growing, but this is the basic concept. Every time we approach a pattern, we want to look at it in these 5 ways if we possibly can.